Example 1 is another type of question which I give a name. I call these questions double triangle questions. And I think you are going to come to love double triangle questions. Initially, when you read a double triangle question, it's probably one where you read and go, I think I'm going to hate this question. That's like the initial gut reaction. It's like, oh my goodness, there's a lot of words already. This looks overly complicated. However, once you get good at recognizing a double triangle question, the steps for solving them are not that hard, and they're usually worth 3 or 4 marks. So it's kind of like, yay, I get 3 or 4 marks on a test or a quiz. That's not that hard to do. So a lot of people like double triangle questions for that reason, because they're very predictable. And I call them double triangle questions because guess how many triangles we're going to have to draw? 2. Maybe I should have called them 2 triangle questions. That'd be shorter to write than double, saving you valuable time. Oh well. So, why are they double triangle questions? Well, they'll have 2 angles, an alpha and a beta. And we're going to have to draw an alpha triangle and a beta triangle. And in double triangle questions, they will always give you a hint into what quadrant each angle is in. This is as easy as it gets. I wonder what quadrant alpha is in. It tells us directly it's in quadrant 3. So I go to quadrant 3, I draw a random angle in quadrant 3, go back to my nearest x-axis. That way I can label my alpha referencing. And they tell us that cos of alpha is 3/5, meaning that cos is adjacent over hypotenuse. This side would be 3, this side would be 5. Me personally, whenever I label sides of a triangle, I keep things positive, and I use my cast rule afterwards to figure out what's positive and negative. A squared plus b squared equals c squared. Do you recognize the famous triangle? Do you know the answer without doing any math? Or do you have to do a squared plus b squared equals c squared to recognize the famous 3, 4, 5 triangle? And so because we have this triangle, we already knew that cos of alpha was negative 3/5. I can now look at my reference angle, and I can say that sine of alpha will be negative 4/5. Negative because it's in quadrant 3, and sine is opposite over hypotenuse. There's my alpha triangle. There's also going to be information for us to draw a triangle with beta. Again, really obvious that beta is in quadrant 2 because they tell us directly. But sometimes they'll give you like more obscure hints. Like they'll say sine of beta is 1/3 and cos of beta is less than 0. Then you would have to use your cast rule to say, I know sine is positive and I know cos is negative. That only happens in quadrant 2. So that's where the double triangle have a little bit extra. You'd have to figure out the quadrant. But if you use your cast rule, it's pretty obvious. Now we draw an angle in quadrant 2. We always go back to the nearest x-axis so we can label our reference angle. And sine is opposite over hypotenuse. And a squared plus b squared equals c squared will give me the square root of 8. Maybe I'll do that. I like color coding. So I'll do that in green because that I actually had to figure out. The blue was told to me in the question. The green I figured out. So I know already that sine of beta was 1/3. From my triangle, I now know that cos of beta, because it's in quadrant 2, it's negative, is negative root 8 over 3. we want to find the exact value of sine of alpha plus beta, and if I look at my formula sheet, sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. So the double triangle questions, you draw two triangles so you can get all of the values you want. Then when we want to find the exact value of sine alpha plus beta, we have a formula for adding two angles. We write that out. And the next thing you need to do is just plug in your information. However, there's a very common mistake that happens next. And in all of my years of teaching, whatever way you decide to do it on your own right now is the way that you would do it on your test the first time you do a question like this. Even if I tell you the right way and point out the wrong way, whatever you choose right now is the way you would do it on a test. And usually it's about 50% of students pick the wrong way. So I always do statistics. So we're all going to write, without me telling you what's right and wrong, what you think you should write in the next line. You've got your information here from your triangles. We just need to plug in things for the next line. Just plug it in. I'm going to come around and do the survey and see, is this class at 50%? Are we above average? Are we below average? And then if you make the mistake, right, and you see the mistake, and you're aware that you were genetically defective, like this is like, I think it's genetic. If you're going to make a mistake, it's not your fault. It's genetics. But if you make the mistake now, and we correct it, there's less chance you make it again. And that's the hope. So plug things in. I'm going to come around and do statistics. For those of you, the 50% that did it wrong, we want to make sure we don't do this again. But it's so tempting to get it wrong. Okay. What you do when you get it wrong is you are so used to when you plug something in, you plug it in for a variable. So the mistake is plugging in -4/5 for alpha. But the question here, does this say alpha equals? No, it says sine of alpha equals, which means I replace all of that with -4/5. There's no sine anymore. Does that make sense? If it said alpha equals, then you replace the alpha. But it doesn't say alpha equals. We don't know what alpha is. But we know that all of sine alpha is equal to -4/5. And we know all of cos beta is -√8/3. Plus all of cos alpha is -3/5. And all of sine beta is 1/3. So the sine and cos go away. So the number one mistake is people keep the sine and cos. And you would, if I showed you the right way, you would still make that mistake the first time. Like I said, I think it might be a genetic thing. However, it's fixable, because if you make the mistake the first time and see the mistake and see why it's a mistake, then your chances of making it again are less. But if I just showed you the right way, most people go, oh, that's not going to happen to me. And then they genetically go and do it the wrong way the first time. I think there's a reason I don't teach biology. I don't think math errors are genetic. Okay, so now we need to write our answer as a simplified final, well, not simplified, you don't have to simplify, but you see that you would have a common denominator of 15. You do need to write your answer as a single fraction in the end. And I would get +4√8. You could simplify that, but don't need to. -3 all over 15. And these are double triangle questions. There's always going to be enough information to draw your triangles in the right quadrants. The quadrants are important for getting your signs right, positive or negative, because you're going to use your cast rule. You'll have to use a squared plus b squared equals c squared to find the other side. And then plugging things into the formula is where you have to be careful that you are replacing all of the sine alpha with the value. Because you don't know alpha, you know all of sine alpha. Questions for practice on this one are 8 and 13.